Consider the following problem. Create a method that takes an array of string and another string and adds that other string to the array. So first, in order to make the method, we need public static returns an array of string, and let's call this add, and it takes an array of string as a parameter and another string, and we want to add the value to the array. Now, how would we do this? Well, we can't just change the length of ARR and directly add it. ARR has some fixed length, and we need to make a new array in order to adjust that length. So we would need string array new ARR or something like that equals new string of length ARR.length plus 1. That way we have room to fit this value into this array. So then we would need to do for int I equals 0, I is less than ARR.length, I plus plus. And then we would need to do new ARR of I equals ARR of I, new ARR of ARR.length equals val, and that would add the value to the array, and then I return new ARR. So then if I do string array, let's just call this array equals QWE ASD ZXC, and we want to add, say, DEF to the array, and then we try to print this array, and then we get another problem, which is that when you print an array, you don't get any useful information, unfortunately. So then we would need to actually, instead of doing this, which gives useless information, we would need to do the following: loop through every element of the array and then print it. And that's where we get our other problem. We supposedly added DEF into our array, but we only have 3 elements here. So why is that? Well, that's because add actually, in fact, returns an array. It doesn't modify the original array, and we can't just modify the original array because we can't do that inside the method, since the original array has a fixed length. Now, if we were to do something like ARR equals new ARR, that still doesn't do anything, because remember that ARR equals new ARR only changes the pointer from this ARR to the new ARR, but it doesn't change the ARR here. So no matter what, I can't do that. So therefore, when I call this method, I would actually need to make ARR equal to what this thing returns, like that. And now when we run it, it should work properly, as shown below. Now, this is a very annoying process. As you can clearly see, we have to do all of this just to be able to add an element into an array and print the array. This motivates the use of an array list. So in order to use that, we must first import it. So import java.util.ArrayList or import java.util.star. And then afterward, to construct an array list of, say, string list equals new array list of string, and this creates an empty array list with no elements. And then I can start adding elements. So list.add QWE, list.add ASD, list.add ZXC. Then afterward, now that we have these elements, now let's start the main process. So we need to add an element to this list. Well, here we need this, and we need this entire method right here. But with an array list, I can just do the following, just list.add def. And now I want to print the list, and it turns out that ArrayList has a good toString method, so when you print the list, it prints all the elements. And in fact, you're also able to loop through the elements of an array list should you find yourself needing to do this. So for every string in the array, for example, print it. So that works as well, as shown below. So using an array list for this type of situation is much better than using an array for this type of situation. We can also do other things with lists. So first we can add elements in the middle of the list. So list.add, so first say the location, and then the thing we want to add, let's just say ABC. And now when we print the list, we get that ABC is added into location 2, where this is location 0, that's location 1, and that's location 2, as shown below. We can also get the size of an array list, much like we can get the size of an array. So for this one, we just do the name of the list and then .size as a method. Then it returns the size as shown below, which is 5 in this case. You can also get individual elements, much like you can in an array. So in order to do that, we do list.get and then the index. So let's just say 1. Remember that we start from 0, so that's 0, that's 1, and that would print ASD as shown below. There's also a set method if you just want to set an individual element. So if we do list.set, and then again always location, so let's say 3 comma, let's just set it to WER. And now when we print the list, we get that location 3 is now WER instead of what it was previously. Also, we can remove elements. So like, for example, list.remove and then index. So let's just say 1, we don't want ASD anymore. Then now when we print the list, it removes that element at the specified index. And we can also insert duplicate values into the list, just like we can for an array. So list.add ABC, and that's a duplicate, and that's allowed. So now we can also remove a specific value from the list. So list.remove specific values, so say ABC. And now, what does this do? When we remove a specific value, it removes the first occurrence of the value from the list if it exists. So when we print the list, it removes the first ABC, but it doesn't remove the second ABC, as shown below. So now the list has 4 elements right here. And finally, we also have the contains method, which returns a boolean of whether the list contains an element. So list.contains, say ZXC, and that's false because ZXC is no longer in the list, even though it was in the past. However, if we do list.contains, say QWE, that would be true, as shown below. Now, sometimes if you misuse these methods, it can be bad. So first of all, when we do the add method, currently we have these 4 elements, right? Be free to add like any normal place, like 0, for example, and it would work. We can also add to say location 5 with say POI. Then when I print the list, since this is location 0, 1, 2, 3, 4, 5 would just be at the end of the list. So this would just be the same thing as adding it to the end of the list. So adding without the location. However, if we do an absurd index, it would be bad. So if we add, say, -1 and then QWE, that would cause an error. It would cause an index out of bounds exception because you can't insert elements at a negative index. Similarly, if I were to change that thing to like 9, which is clearly out of bounds right now, then it'll also cause an index out of bounds exception. However, if I make it 6, even though the array currently has 6 elements and there is no index 6, we can create one because then the array will have 7 elements, which would make it have an index 6, as shown below. Similarly, if we get out of index, it's bad as well. So if we try list.get, say 6, it would work right now because, well, the array currently has 7 elements. Now if we do list.get, say 7, however, that's bad, and it'll cause the index out of bounds exception because, well, even though we're allowed to do list.add 7, we're not allowed to do list.get 7 because get doesn't make a new position. So basically we're trying to access 0, 1, 2, 3, 4, 5, 6, 7, which doesn't exactly exist. Similarly, if we do something like -2, that's also not going to work, and it will cause an index out of bounds exception. Similarly, when we set, we also must be in range. So adding index must be from 0 to the size inclusive. However, getting or setting index must be from 0 to size -1 inclusive, because we can't get the element at index size, similar to how we can't get the element at index a length of an array. So then, what about removing? List.remove 0, that would work properly. So now when we print the list, it would only have 6 elements right here. However, if we try something like list.remove, say -1, then what would happen? It would cause an index out of bounds exception. What if I try now 6, which is no longer an index of the array list? Then it'll also cause an index out of bounds exception. So getting, setting, or removing index must be from 0 to size -1 inclusive. However, if I try to remove a value, even if the value is clearly not in the array list, I can still get it to work. It's just not going to do anything. Now currently our array list has just been dealing with strings. And why is that? Well, that's because we put string in between these angle brackets, which are less than and greater than signs, by the way. Just like how we put string here, so now this array contains strings. When we put string here, this list contains strings. And in general, ArrayList is something called a generic class, which in short basically means that I can put any object type right here, and then it'll be suited to that object type. So for example, I can do ArrayList of object obj list equals new ArrayList of object, for example. I can even do ArrayList of scanner like so. I can do basically any object type. However, I cannot do something like ArrayList of, say, int. This is something that's not allowed. Every type of the array list must have the properties of an object. As shown below, it says unexpected type. I must make this an object type. Now, how do I fix this? Because I might actually want an array list of numbers. Well, the way I do this is to change this into integer, which is the wrapper class for int. And now it works. Since integer shares the properties of objects, it would work. And the nice thing about this is that when I add elements to this list, say int list.add 7, it works. I don't need to put this in integer form because Java would automatically convert this into integer form. So I can add elements. And just as an exercise, what would the list contain after these addings? It would contain 6, 3, 7, 8 in that order because, well, after this, it's 7. After this, I added 6 to location 0, so now it's 6, 7. And then I add 8 to the end, so 6, 7, 8. And then I add 3 to location 1, so it's 6, 3, 7, 8. And now, there's only one problem with this, and it comes in the remove method. So if I try int list.remove, let's say I want to remove an index, that would work perfectly. So when I print the list, it would be 6, 3, 8. As shown below. However, what if I want to remove a value? Well, then we would need to make this an integer form, because if we just do remove 3, it'll think we're removing index 3, which is going to cause an error because there is no index 3. So instead, we need to put this into integer format. How would we do this? Well, we just make a new integer and put that inside that integer, or we just directly pass in an integer variable. And then it would remove that. So then, now, when we print the list, it would remove the 3. So 6, 8, as shown below. Notice that double, for example, remember we still need to make this capital double, does not have the same problem. Int is the only one that has this problem. So when I try this, so if I do double list.add 5.7, adding works properly. Now notice that if I do double list.add 3, I would have to be careful because as we noted right here, we can't convert int directly up to capital double. We would need to do like 3.0 or cast it to a lowercase double. And then now, if I want to do something like double list.remove, I can remove the value, like 5.7, and it wouldn't cause the same problem. I wouldn't have to cast it to or construct a capital double. For integer, because int and integer are so similar, we need to make this an integer in order to specify whether we're removing the index or value, but for double, we don't need to do that. And now, back here, we introduced the array list of object, but actually, if we use an array list of object, since object is the universal superclass, everything extends object unless they're primitive data types, which are not included in here. So then if I do obj list2 equals new array list, this would work. And basically it says that without angle brackets, the type is automatically object. Now, another thing we can do with ArrayList is have an array list of arrays. So for example, array list of int array, ArrayList equals new array list of int array. That's allowed because actually arrays contain the properties of an object. You cannot have an array list of int, but you can of int array. Even though int array is an array of primitive data types, it still has the properties of an object. So ArrayList.add, let's just say new int 457. Now be aware about doing this though, because when you create an array list of arrays, we should realize that arrays don't have a good toString method. So when we print the ARR list right here, it won't give any good information. And why is that? Well, ArrayList just uses the toString method of the type in here, because every object has a toString method, but arrays don't have a good toString method. So just be careful about that. You can also create array lists of array lists. So array list of integer, list, for example. Like so. And now we can do, for example, list.add int list and list.add an empty array list of integer. And now when I print this list, it'll show as this int list, which was 6.8 last time we left it, and an empty array list. And notice that we're able to print this properly because ArrayList uses the types toString method. So this time for each element, it uses the ArrayList toString method, which in turn uses the integer toString method. So this thing would work. Now, what happens if you want to create, instead of, say, an array list of arrays, you want to create an array of array lists? How would you do this? Well, let's see. Array list of integers, let's just say array, and then list ARR, array of lists, equals new array list of integer. Would this work? Well, it turns out actually it wouldn't. And the way you do this is actually just don't put the generic at the end of the array. So basically like this. So you put the generic on the left side but not the right side. And this may cause a warning in the compiler, but it's still going to work. So if I do, for example, list ARR of 2 equals new array list of integer, list ARR of 1 equals, say, for example, int list. Now you do have to be careful when making arrays like this, because any arrays of objects are by default null. So if we try printing everything, then the following thing will happen. It'll just do null and then our elements and then null, because, well, we didn't put anything there, so it's null by default. And if we try to access, like, say, size, then it would actually cause a null pointer exception. So just be careful of that again. And ArrayList doesn't exactly have that issue unless you specifically insert a null, which I don't see why you would do. Now let's try creating array lists of our own classes. So let's just say we have a class rectangle, and let's just do double length and width, and public rectangle, double L, double W constructor, and then length equals L, width equals W, and an area method, because why not? And now let's try creating array lists of rectangles. So, array list of rectangle. Rect list equals new array list of rectangle. And let's add the few rectangles to it. Just say we have that, and now let's try printing the list. So what would happen? Well, actually, it would give no useful information. And the reason is because, well, we need a toString method in order for it to give the useful information. Since ArrayList's toString method for each element uses the elements toString method. So therefore, we need a public string toString, and let's just return length and cross width, like that. And now when we run, it gives proper information. Now let's try some other methods. Say, for instance, the contains method. Now what will that print? Well, actually it'll print false if I print it. As shown below. The reason is because we don't have an equals method. And the contains method in ArrayList checks the equals method in order to determine whether the result's true or false. So therefore we also need an equals method here. So public boolean equals object O if O is null, return false. If O is not an instance of rectangle, return false. Then cast it to rectangle. Then if length equals r dot length and width equals r dot width, then return true, and otherwise return false. So basically return length equals r dot length and width equals r dot width. And now that contains method will return true. Or in the case where, let's just say I put 9.6, it'll return false. And also, the equals method is needed for the removing of value. So remove new rectangle 9.5, and then let's print the list afterward. Then let's run, and it removed the thing successfully. And let's say we were to comment out this equals method, then what would happen? Well, then it would just not remove it properly, because the remove, just like the contains, checks the equals method if we're removing a specific value. So in general, note that when you create a class and you want an array list of that class, you need a toString method in order to print the array list properly, and you need an equals method if you want to check the contains method or remove a specific value from the list.